Hello guys, welcome back to another Puzzle Street video. Today I have yet another question here, and as always, let's first start by reading the question. So, let x in square brackets denote the greatest integer less than or equal to x. So for example, 3.1 in these square brackets will be equal to 3, and negative 1.4 will be equal to negative 2. Now, for x bigger than 0, define the function fx, where fx is going to be equal to x plus 1 over x in square brackets minus x plus 1 over x in these square brackets. So now we have two parts to this question, okay? The first part is going to be to determine all x bigger than 0, so that fx equals x. So let's first work on this, and let's ignore the second part for now. Now here, I'm going to go down here. You can see here that x is going to be bigger than 1, obviously. And so this means that if x is going to be bigger than 1, we can have 1 over x be in between 0 and 1, like so. And obviously this means that their sum is going to be bigger than 1. And we can do the same thing, but reversed. So if x is smaller than 0, this means that 1 over x is going to be bigger than 0. And so, then again, same thing, x plus 1 over x is going to be bigger than 1. So now we know that x plus 1 over x is obviously going to be bigger than 1, right? So now we're going to let's let fx be equal to x. As we're trying to prove that this is, well, it works. So this can then be turned into a little right here, x plus 1 over x minus x plus 1 over x in these square brackets. And this is going to be equal to x, right? That's what we're trying to prove. Now here, we can see here that, well, 1 over x is just going to be equal to the square brackets x plus 1 over x. Because we can, as you can see here, there's two sides of the equation here. We have the x here, and then the fx on this side. We can take the x out of these bases and move it over here to cancel them out. So we can leave 1 over x on one side, then we can move the negative x plus 1 over x and square brackets to the other side to change the sign, and you can make it positive, and then we receive this. That's why I have a little arrow here. Okay? So this means that 1 over x is going to have to be an integer. I'll just write an int for integer, right? So now we're going to let x be equal to 1 over 9, and 1 over x be equal to n. Right? So now we can rewrite this equation here into n equals square bracket n plus 1 over n. Okay? And this means that n here is going to have to be, so 1 over n, sorry, is going to have to be in between 0 and 1. And so n has to be bigger than 1. And so the solution here, actually, I'll leave the solution up here to save some space. The solution to this problem here is that x is going to be equal to 1 over n, where n is going to be bigger than 1. Okay, so this is part A. Now let's do part B. Part B is going to be a little bit harder here. We need to prove that if x is equal to a over a plus 1 for some positive integer a bigger than 1, we need to prove that x is not equal to fx, but that fx is going to be equal to f in fx, so fx and f. So here what we're going to do is that we're going to take x plus 1 over x, and we are going to plug in here what x is equal to given in the question. So plugging this in, we can get a over a plus 1 plus a plus 1 over a. Now we're going to need to change the base on the bottom and then add these two together, and this turns into eventually this is going to be a lot of calculation, so I'll just write it out. So it's going to be a squared times a plus 1 squared in brackets, and on the bottom it's just a times a plus 1, and then eventually we can expand this into 2 plus 1 over a squared plus a. Now this is really important here. So now let's just look at 1 over a squared plus a for now by itself. Now since we know that a is bigger than 1, this means that a squared plus a is obviously going to be bigger than 2. And this is because, well, as I just said before, a is bigger than 1. So obviously see here, this is going to be bigger than 1, and this here is going to be bigger than 1 as well. So two numbers that are both bigger than 1 added together is obviously going to be bigger than 2. Now that we have this, we can see that 1 over a squared plus a is going to be in between 0 and 1/2, or 1 over 2. And so this means that this number here, right, 2 plus 1 over a squared plus a, this is going to be in between. I'll actually get rid of this equal sign here. This is going to be in between 2 and 3. So we can take this and we can simplify it, and then we get 2 plus 1 over a squared plus a. And because we know that 1 over a squared plus a has to be in between 0 and 1 over 2, and obviously this is the 2 here, we can add the 2 to both sides. And since 1 over 2 is obviously smaller than 1, we know that this number here has to be in between 2 and 3, and that's all we really need to know here. Because going back to what fx is equal to, so we're going to stray away from this. Fx is equal to x plus 1 over x minus the same thing in square brackets. And the reason why this is so important is because now we know that 1 over a squared plus a is going to be smaller than 1. Okay, it's smaller than 1 over 2, which is smaller than 1. And this means that this number here, in turn, also needs to be in between 2 and 3. So it's a number between 2 and 3. So when you put this value into square brackets, it'll obviously be equal to 2, which is the lowest integer it can be, right? So this can be then turned into, after we plug in this here to here as well, we can get 2 plus 1 over a squared plus a. And this is going to be minus 2, sorry, and this is going to be just equal to 1 over a squared plus a. So this is what fx is equal to. And you can easily tell here that 1 over a squared plus a is not going to be equal to a over a plus 1. How can you tell? Well, let's just say x here is going to be equal to, actually, I'll write here, a plus 1. This cannot be equal to a squared plus a, because let's just multiply a by both sides to make sure that the denominator is the same. As you can see, the two denominators are the same, and yet the numerators are different, and so x and fx cannot be equal to each other. So now let's look at f in fx, or fx and f. Sorry. So essentially, we're just going to be plugging 1 over a squared plus a back into fx. And this is going to be equal to 1 over a squared plus a plus a squared plus a. So this is the stuff in the curly braces, and now next we have the stuff in the square brackets. 1 over a squared plus a squared plus a. Right? And this is going to be equal to 1 over a squared plus a. Actually, wait, I'm going to write this on a new line because it's going into the other place. 1 over a squared plus a squared plus a. And then we can look in here, obviously 1 over a squared plus a, since we know that a squared plus a is going to be bigger than 1, or it's actually bigger than 2. We know that this number here is obviously going to be something below 1. And since we know that a squared and a, since we know that they're both integers, we know that this is just going to be equal to a squared plus a. So minus a squared minus a. Obviously, these two cancel out, and we finally receive 1 over a squared plus a, which is the same as fx. And so fx is going to be equal to fx in fx. And so that's how you prove that, well, x is not going to be equal to fx, and fx is going to be equal to fx and f. So that's it. Thank you guys for listening. If you have any other way to solve this problem, please let me know down below in the comments, and thank you guys for listening. Bye.